Welcome to today's session on k-medoids clustering. So in the last session we have seen about k-means clustering. So this is k-medoids clustering. The k-medoids clustering chooses the data points as centers and works with the generalization of the Manhattan norm to define distance between the data points. That is, it first fixes the center of the cluster, then it groups the data points based on Manhattan normalization and it forms a cluster. So it clusters the data set of n objects into k clusters. Say suppose there are 100 objects and it is clustering that into 5 clusters. So the k is 5 here. To determine what is the size of the k, we use the tool called as Silhouette. Okay, so in k-medoids we use Silhouette to decide on the number of clusters, that is k. Okay, so as in the previous session for k-means we have used the iris data set. So here also we are going to use the iris data set. So I am going to copy the iris data set into iris1 data set and I am going to remove the species part of the iris data set. Let me show you the iris data set, how it looks like. So it has 5 columns: sepal length, sepal width, petal width and species. The species is Setosa, virginica and versicolor. Okay, so there are 3 species of iris flowers. So with the different sepal length, sepal width, petal length and petal width, so on, there are 3 species. So that is there in the iris data set. Now in the iris data set I am going to remove the species column and I am going to store that into iris1. Okay, so for k-medoids clustering we use the function PAMK. Okay, so this PAMK function is there in the library FPC. Okay, so for that we have to first install the FPC package, then we have to invoke the package FPC using the library function, then we have to use the PAMK function to build the clusters for k-medoids using the iris1 dataset. So the result is stored in PMK. So in PMK, if you choose NC, that is the number of clusters, it will show you how many clusters it has formed. So as in the result here, we have 2 clusters. So for k-medoids using PAMK for the iris data set, the number of clusters is 2. Okay, so let me see the classification, let me see the clustering of the iris1 data set by the k-medoids clustering method using the PMK function, PAMK function, and I'm going to compare that with the actual iris species. Okay, so let me see how many objects are properly clustered and how many are not properly clustered using k-medoids. Okay, so here we have 2 clusters. Actually it should be 3 clusters since we have 3 species: Setosa, versicolor and virginica. So but there are only 2 clusters. The first cluster has a 50 Setosa, which is correct, and it has 1 versicolor. So in one cluster itself the other species of the flower is clustered, which is slightly wrong. And in the second cluster you have 49 versicolor and 50 virginica. Okay, so it means a half. This cluster 2 is combining versicolor and virginica 50% each. Okay, so which should have been 3 clusters, one is versicolor, the other one is virginica. Okay, so let me show you this by plotting in a graph by using the plot function. So let me zoom this. See here, you can see 2 clusters formed by k-medoids PAMK function. It is having 2 clusters. One is for Setosa, the other one is a combination of versicolor and virginica. Okay, so this Silhouette is deciding the number of clusters. See here, it is showing there are 2 clusters. The first cluster is 0.81 and the second cluster is 0.62. So the maximum number of clusters here is the silhouette is showing it as 2. Okay. So there are two clusters that we have seen, one for Setosa and the other one is a mixture of versicolor and virginica, and the silhouette shows there are two clusters. The silhouette width is shown between 0.81 to 0.62, that is nearing 1. This means that the observations are all well clustered. So if the silhouette width is around 0, it means observations lies between the two clusters. It is if it is less than 0, it means the observations are placed in the wrong clusters. Okay, so since it is nearing 1, it is properly clustered. Okay, if it is around 0, it is lying between the two clusters. If it is less than 0, it is wrongly clustered. Okay, so this is what we understand from using PAMK. So there is another function which is PAM for k-medioids clustering. So for that we use the library cluster. Okay, so let me run this library cluster and I build the PAM using the PAM function. I build 3 clusters using IRIS1 dataset, and I am comparing that with the actual iris species, and it is showing 3 clusters. The first cluster having Setosa 50, and the second cluster having versicolor 48 and virginica 14, and the third cluster having 2 versicolor and 36 virginica. Okay, so let me plot this in a graph. See here, we can see 3 clusters. So one is Setosa, another one is versicolor, another one is virginica. The other 2 clusters are overlapping. So that is why we have some part of virginica in versicolor cluster and some part of versicolor in virginica cluster. See here in the silhouette, here it is showing there are it has 3 clusters. Okay, so this silhouette is a tool which helps us to decide on the number of clusters for the given data. So here cluster 1 with only Setosa species, and cluster 2 with mostly versicolor species and few of virginica species, and in cluster 3 we have mostly virginica species and few of versicolor species. The lines between the clusters shows the distance between the clusters. See here you can see 2 pink lines, so that shows the distance between the clusters. Okay. So this is how we understand k-medioids clustering using the packages available in our programming. Okay, hope it was a useful session. Let us see in the next session.